Grounding and bounding are two of the most misunderstood concepts in all electrical work. Many apprentices think they are the same thing, but they serve completely different safety functions. Today we're breaking down grounding versus bounding under the Ontario Electrical Safety Code. Let's break this down. Rule 10-102, grounding electrodes. It also refers you to see Appendix B. See Bulletin 10-17-7. 10-102, Subrule 1. Grounding electrodes shall consist of manufactured grounding electrode, field assembly grounding electrodes, or in situ grounding electrode forming part of existing infrastructure. Rule 10-102, Subrule 2. Manufactured grounding electrode shall, A, in the case of a ground rod electrode, consist of two rod electrodes, I, spaced not less than 3 meters apart, interconnected with a grounding conductor size as prescribed for grounding conductors and driven to the full length of the rod. In the case of chemical charged rod electrode, be installed to the full length of the rod, or in the case of a plate electrode, be in direct contact with exterior soil at not less than 600 millimeters below grade level, or encased within the bottom 50 millimeters of your concrete foundation footing in direct contact with the earth at not less than 600 millimeters below grade, finished grade. Number 3, Subrule 3. A field assembly grounding electrode shall consist of a bare copper conductor not less than 6 meters in length, size in accordance with Table 43, and encased within the bottom 50 millimeters of a concrete foundation footing in direct contact with the earth at not less than 600 millimeters below finished grade, or a bare copper conductor not less than 6 meters in length, size in accordance with Table 43, and direct burial in earth at least 600 millimeters below finished grade. For the purpose of Rule 2-024, an in-situ grounding electrode shall not be considered electrical equipment and shall provide at 600 millimeters or more below finished grade a surface area exposure to earth equivalent to that of a similar manufactured grounding electrode. Where your local conditions such as rock or permitted prevents a grounded electrode from being installed at the required buried depth, a lesser acceptable depth shall be permitted. So Rule 10-102 has taken us to Bulletin 10-17-7, and this is what it states. Grounding conductors entry into the branch section of a combination panel board, that's 1-2-12-2 NMSC service grounding conductor. Installation of ground electrodes at less than the required depth. Metallic water pipe as in situ grounding electrodes. Also goes on to say, grounding conductor entry into the branch section of a combination panel board. We have been asked if the system grounding conductor may enter the panel board through the branch circuit section of a combination panel. Traditionally, the system grounding conductor has been required to enter service equipment as close as practical to the point of connection within the equipment. It was not permitted to route the system grounding conductors through the branch circuit compartment of a combination panel to the main breaker compartment. There is no rule in the Ontario Electrical Safety Code prohibiting this practice. It is permissible to route the system grounding conductor through the branch circuit compartment of a service entrance radio combination panel as long as no alteration of the main breaker compartment barrier is required. System grounding conductors may also be installed in the same raceway as the consumer service conductor, subject to the provision of Rule 10-1165, and provided that they do not interfere with the installation of the service conductors by a supply authority. In all cases, the system grounding conductor shall terminate at the main neutral bar in the main breaker compartment of the panel board. 2. 12-2 NMSC service grounding conductor. Many older services have a 12-2 NMSC installed at the service grounding conductor, and the question is often asked is if required to be replaced with a conductor meeting Rule 10-114. To ensure consistency, the following shall apply. 1. When upgrading service equipment panels to increase amplicity, it is mandatory the existing 12-2 NMSC service grounding conductor be replaced to meet the minimum requirements of Rule 10-114. When changing service equipment panels from fuses to breakers but not increasing amplicity, the existing 12-2 NMSC service grounding conductor shall be permitted to remain. When replacing load center panel boards with no alteration to the service box, the existing 12-2 NMSC service grounding conductor shall be permitted to remain. When an existing 12-2 service grounding conductor is utilized, the termination point on the ground electrode shall be inspected to ensure an approved ground clamps is installed and there is no corrosion at the connection point. 12-2 NMSC has an amplicity equal to a number 8 copper conductor, which was permitted by Table 12 as a grounding conductor for 100 amp service rated conductors prior to the 2012 code. Installation of ground electrode at less than the required depth. Rule 10-1025 states that where a local connection such as rock or permafrost prevents a rod or plate electrode from being installed at the required buried depth, a lesser acceptable depth shall be permitted. Questions 1. What lesser acceptable depth shall be permitted? Answer. For a plate electrode where a local condition such as rock or permafrost prevents compliance with the 600 millimeters buried depth, a lesser depth is permitted provided 450 millimeters granular material or 100 millimeters concrete used to provide a cover to the grounding plate. For a rod electrode where rock bottom is encountered at a depth of 1.2 meters or above, each rod shall be driven to rock bottom and the remainder buried at least 600 millimeters below finish grade level in horizontal trench, or where the rock bottoms is encountered at a depth of less than 1.2 meters, each rod shall be buried at least 600 millimeters below finish grade level in horizontal trench. Metallic water pipe as in-situ grounding electrode. A metallic water pipe conductively in contact with earth is recognized as in-situ grounding electrode based on the Appendix B note to Rule 10-102. In-situ grounding electrode is required to have a surface area contact with the earth equivalent to that provided by manufactured electrode. A metallic water pipe system located at least 600 millimeters below finish grade and extending 3 meters has traditionally been recognized as an acceptable in-situ grounding electrode. There is no question code requirements where the grounding electrode should be attached to a metallic water pipe if a grounding conductor is connected to the customer's side of the water meter and there are insulated joints or sections such as plastic water meter. A bonding jumper shall be installed so that there are no insulating sections between the point of attachment and the point of which the electrode makes contact with earth. Some manufacturers have requirements that do not allow the municipal water system to be used as an in-situ grounding electrode. In these circumstances, an alternative electrode means for grounding in accordance with Rule 10-102 should be permitted. Furthermore, a provision for electricians isolating the municipal water system from the building water system, example, an insulation section at that point of entrance of the water service to the building should be in place before bonding the building metallic water pipe system in accordance with Rule 10-700. Ungrounded systems. Rules 10-400 ungrounded systems also tells you to see Appendix B. 1. DC or AC systems shall be permitted to be ungrounded, provided that the system is equipped with the suitable ground fault detection, and B, maintained by qualified persons. 2. On the occurrence of a ground fault, the ground fault detection shall activate a visual or audible alarm to indicate the presence of the ground fault. 3. The alarm required by Sub-Rule 2 and any extra, example, redundant alarms if installed, shall be clearly labeled as to their purpose, clearly enunciate the status of the system to persons monitoring it, and continue signaling until the condition has been corrected. Extra low voltage DC or AC systems shall be permitted to be ungrounded without having to comply with the ground fault detection requirements specified in Sub-Rule 1 to 3. It also is sending us to Appendix B. Appendix B, Rule 10-400, goes on to say, ungrounded systems have traditionally been used for an added degree of service continuity and reliability. However, a fall on the phase of a three-phase ungrounded system places a sustained increased voltage on the insulation of the underground phases, which tends to reduce the life of insulation. Although ungrounded systems are still permitted by the code, they are increasingly being replaced by independent grounded systems, which provide better voltage to ground stability. Ungrounded systems may provide greater continuity of operation in the event of a ground fault. However, a second fault can be more catastrophic than a grounded system fault. Whenever ungrounded systems are used, it is important that qualified persons monitor the system on a regular basis for early identification of ground faults so that timely corrective action of the first ground fault can be made before a second ground fault occurs. Rule 10-606, bonding continuity at other than service equipment. It also tells you to see Appendix B. Bonding continuity of metal raceways, metal sheeted cable, or armored cable shall be assured by one of the methods specified in Rule 10-604. 1. Or by using a standard box connectors made up type. 2 lock nuts, one inside and one outside of boxes and cabinets, or 1 lock nut and a metal conduit bushing, provided that the bushing can be installed so that it is mechanically secure and makes positive contact with the inside surface of the box or cabinet. Reducing washers shall not be used to maintain the bending continuity of the wiring system. So in Rule 10-606, it's also sending us to 10-604, where we must go to follow up. 1. The bonding continuity for service racers, cable armor, cable sheet, and all service equipment enclosures containing service conductors, including meter fittings, boxes, or the like, shall be. So Appendix B 10-606 tells us reducing washers are not tested for their suitability for maintaining a bonding connection. The use of reducing washers to maintain bonding continuity is a misapplication of the product and non-conformance with Rule 2-024. So again, always remember, grounding stabilizes voltage to the earth. Bonding allows fault current to return and trip the breaker. Hot wire attachers panel enclosure. Bonding conductors carry fault current. Breaker trips immediately. Without bonding, dangerous metals energize. This is where many apprentices get confused. As you can see from here in this diagram, you have your grounding system, which normally comes in from the your main supply will bring in your feeders from your transformer, comes into your home, and you will see the ground rod, which is placed below the depth of the ground, goes straight down into the ground. You tie off of the your grounding system, which goes back to your panel, whether it be a ground rod or it be a ground plate, whichever one is approved is what we're going to use according to your local authorities. Second drawing is all metal parts must stay bonded together. As you can see, here you have your bonded wire coming back from your main panel. Very important that your metal parts must be connected together, all tied into the same system, as it has to be dissipated back to the earth. The last diagram is no bonding fault path. As you can see, it's a hazard. It energizes the panel. No path short hazards. You become the path to ground. And what happens is you're caught in the middle of that path, and you now become the closest point to ground. So again, pay attention when you are doing a service upgrade or a service change. Bonding and grounding are not the same. So the object of bonding metal parts and metal system together and to the grounded system conductor is simply to reduce the danger of electrical shock or property damage by providing a low impedance path for fault current back to the source to establish an equal potential planes such that the possibility of a potential difference between metal parts is minimized. The object of grounding the electrical system and non-current carrying metal parts is to connect the earth to the equal potential plane, thereby minimizing any potential difference to earth. The object of using an ungrounded system or a system incorporating neutral grounding devices is to provide an alternative to a solidly grounded system, thereby limiting the magnitude of current and minimize the damage resulting from a single fault. So there you have it. So this is section 10-400 and 10-102 and also 10-606 with also bulletins that leads us back to the code rule. So basically this is how I go about my normally daily tasks of incorporating the OESC 2024 code rules into real world situations by applying these rules from the code into the real world. It helps saves lives and also saves and also stop the hazards of equipments from being energized in the real world. Every grounding and bonding system is different. Referring back to your code book will also allow you to do the job accordingly. As you can see, in some areas there's ground rods that are replaced with ground plates. Again, it all depends on the authority, your safety authority in that area, and what the code rule states also. So again, very important to make sure that you do follow these code rules. As you can see, if you do follow me on this channel, a couple of my videos you will see where I've actually done the grounding and bonding according to the OESC 2024. You will see in the ground plate, I would place my ground plate into the floor on the outdoor of the home. My ground wire that's attached to the ground plate, obviously there's a certain depth, obviously there's a certain size of ground wire you have to use, which you would then bring into the home itself. Either you would tie that off into your main panel, or if your main panel is being relocated to another spot, the disconnect becomes your main point of bonding and grounding. Also, you will see me in one of my other videos too, where I did a bonding of the pool metal parts, all metal parts. Again, I don't want to get into the bonding of the pool because it's a different, it's going to be a different series, but metal parts, everything has to connect back to the system. Everything has to be done according to the code. Following the code allows you to sleep a little bit better, knowing that your work was done according to your OESC 2024, knowing that your work will be inspected by the inspector. It also gives you a peace of mind. So again, for all those who hasn't subscribed to the channel, don't forget to hit that subscribe button. Don't forget you can also become a member of the channel, and also you can also catch the Masterclass series that's going to pop up on the screen once this video is done. And I will catch you guys on the next video.